Today we're gonna talk about a few stuff. We're gonna start with EFS, and also I'm gonna add a few things. Like I'm gonna do a simple architecture based on the understanding about EC2 instance and elastic IPs and EBS, and we're gonna add EFS, and we're gonna do our very own. We're gonna start our very own architecture. So that's one of the questions that I get in the solutions architect exam. So let's start. Today we're gonna talk about, by the way, EFS and FSx, which are options for EC2 storage options. I think FSx is a storage option for EC2. The main difference between FSx and EFS that EFS is for Amazon, you see here, and FSx is a third-party file system. So yeah. Okay, so the basic understanding, we took a full week of Linux, so we've understood what do we mean by a file system, because Linux is a file system. So we have seen the root path, the bin, the user, these kind of paths. I don't want to say them again, but these kind of architectures helps us with a thing that is called a file system. So as you can see here, if we get really close, so it's a cloud, it's a scalable, and you can see a file right there. So that's what I need. So again, we said it's scalable, and of course it's in the cloud, so it's managed, and it's a file storage services that you use with Amazon EC2 instance. Also, it provides simple, scalable, elastic system for Linux-based workloads. So please, I'm gonna put underline for this. So Linux-based workloads. If you have in the exam, we want a file system for Linux-based workloads, or for Linux, you're gonna answer with EFS. We're gonna check out the notes right now. Okay, so basically EFS, we have talked about it. It's a file system, so it's compatibility for Linux AMIs. Oh, sorry. So Linux AMIs, not Windows. It's what's called a POSIX file system. So POSIX is for Linux file system. It's we can say it like a, oh, no, that's gone. Okay, so we can say that POSIX is related to Linux, and as we said, so EFS Linux. That's what I want you to understand. So if you remember when we gave the Linux week, we've talked about the mount and media, and we have said that if you want to mount something to Linux, or you want to mount a file system, you use this term, or this concept of what's called mounting. So we can mount up to 100 instances across different availability zones, and it uses EC2 NICs to mount. Okay, what is a NIC? So basically, we have a few concepts. So we have the concept of MAC address, or MACs in particular. We have IP addresses, and we have something that's called internet network. What's called? I forgot. Okay, it's not called NIC in Computing 101. It's called in a different name. I forgot its name. The thing that you connect with the internet. It's the same as a NIC right here. So let's internet NIC. NIC card. Okay. Yeah, this is a network adapter. This is a NIC card for EC2 instance. So this gives you the ability to connect to the internet. And without the network adapter, I don't think you can connect to the internet. So here, it's installed on the computer if it's not, and it can connect to an internet or a network. Typically, internet, yeah. Okay, so we have this thing called EC2 NICs, which is a network interface card, and EFS uses NICs to mount, so to mount. Like this is our NIC. Wait, let me. Okay. This is our NIC, as you can see here, my AirPod box. And when we want to mount EFS, which is this band-aid, so it goes on like this. So this is the EFS, you mount it on the AirPod box. I'm joking. NIC card. Okay, so we have different use cases. We have the first use case, like why do we use EFS or elastic file systems? So EFS elastic file system. Why do we use it? Of course, big data analytics. We need those, and we're gonna see why when we try and draw our first architecture. Content management, so it serves large scale users. Of course, it sizes observing so share information for files across multiple instances. Okay, so let's go and take a look at EFS. So here we have EFS. And let's read like a little bit about it. So if we check here, it is an NFS or network file system. And it's gonna talk a lot. You can check out the video. It's a file system. So Amazon Elastic File System, EFS, provides NFS file systems. So it benefits that is it's very scalable and elastic. It's fully managed and it's shared file storage. So yeah. So also you can like collaborate with a lot of cloud services. So if we open on EFS, AWS docs or documentation, you're gonna have the full documentation of EFS, as you can see here. So user guide. I don't want a user guide, so let's getting started with EFS. So as you can see here, you can create. You need some prerequisites, a few stuff. Yeah. Okay. So we talked about why do we use EFS. So we have things that are called performance mode. So let's go and create a file system. And then optional, let's call it a file system. I want to customize. So let's check out the things we have. Okay. So first thing we have said that it serves up to 100 instances, different AZs or the same AZs, it's fine. So here we can see that it is regional, so it serves a regional, as you can see here, so across multiple availability zones within an AWS region. Okay. So we have backups. You can enable automatic backups. We're gonna talk about life management. So let's go through performance settings, which is gonna be here right now. Okay, so performance mode, we have elastic, so general purpose, or we have this thing that is called max input output. If you remember yesterday when we talked about EBS, we talked about input output and throughput. So let's start with the general purpose. So we have low latency. Of course, that's what we need. So low latency is much better than high latency. What do we mean by latency is basically if we have here, if we have here a user and he's trying to reach a server, so the time that this thing happened, this is called latency. So the lower the latency we have, the better, of course. And that's what we need. So it gives us low latency. It's ideal for sensitive cases or latency sensitive cases, such as web serving environments, content management systems, and development of environments. So we said that the time that responses and requests happen between a server and a user, this is called latency, and we're gonna make it, and I don't know why I'm using different ones, but it's more fun, I guess. So we're gonna write the lower the latency, the better. So the lower the latency, let me make it bigger. So the better. Of course, the lower the latency, the better it is. Why did it write it like that? That's fine. Let me ungroup it. Put this like right here. So I didn't do anything. Okay, so the lower the latency, the better it is. Okay. So we have another mode which is called max input output. So it has a bit higher latency than the general one, and it has a higher aggregated throughput. So it's suitable for highly parallelized applications and workloads such as big data and big data analysis and media processing. So basically, when we have big data or what's called where it is here, this a parallelized application, what it means is that we have, let me go to uploads and have like a few instances. I need to make them all smaller. So this application is what is called, right, that's enough, 3 is enough. Okay, so you send data or you like divide data between these 3 instances. And then why is it like this? Let's do this, and then this. Okay. So then we're gonna have this, this, this. Okay. So when you put like when you give EC2 instances data, that needs to be analyzed. And of course, big data, you're talking about terabytes and multiple gigabytes of data. So if you put it on one instance, it's going to take a lot of time. So the best practice is to put it in parallel computing that does the same work, but it segments the data. So if we have like a very huge data, we can segment them like we see here into 3 EC2 instances, and then the data is analyzed. This is what's called a parallel application. This is mostly used for big data and data analysis. Of course, we also, this concept is data warehousing. So if we go to data warehousing, parallels, so I think we're going to see that big data does the same thing. As you can see here, that it segments the data into shards for a few things, then it gives you the data analyzed. Okay, so we saw the use case, we've talked about the general purpose and the max input output, so let's go on throughput mode. So we have both mode, we have provision and we have bursting. So I think this is new, that's fine. So here we can have bursting. So bursting, I think it's automatically adjusts. So you have to like, it's scalable. It automatically adjusts the throughput performance based on the size of your file system. And this mode is designed to handle various activity or levels of activity. So this is for unpredictable workloads. So bursting, like burst. So imagine you have a balloon and then you're trying to squish it, and it's like every time you squish it, it gets bigger. So you kind of like see where I'm going. So let's put a balloon on bursting. Let's go to images, give some stickers, and let's balloon. Yeah, this is perfect. This is bursting. So as much as you put air into it, it's gonna give you the workload that you need. Provisioned is the total opposite of bursting. So this is, you have a steady throughput where it is. So, yeah. Constant performance. So you know what you're dealing with. You have something that is you know what's me, you know, it's the totally opposite of bursting. So you know what you're dealing with or the kind of file system you're dealing with. So this is suitable for consistent performance and it's good for high and steady. You see here, steady throughput requirements. So again, we have two throughputs mode. We have the bursting and provisioned, as you can see here. So here we have bursting. If we go to learn more, we can see that. It provides throughputs to scale as much as it needs. Okay, so we have storage classes. Also, we have something that's called standard, and we have something that's called infrequent access, or IA, not AI. Of course, infrequent access is also related to S3 buckets. We have infrequent access S3 buckets. Those are lower in cost, but the retrieval cost is higher. So let's draw a file system, or maybe I have a file system. Yeah, here it is. Okay, so let's say that I just want something for archiving. So I want, let's give, oh, sorry. So we have two use cases. The first one is gonna be our standard use case. So we can see that the user is sending and receiving from the file system. So in this purpose or in this use case, we can understand that we need to use the standard one. So standard one. Why? Because the user is sending and retrieving data in a constant way, so not in an infrequent way. But in the IA, okay, it is IA, the user is the user is kind of like sending and very low, like you can sending and maybe he can get one error. So maybe like in an infrequent time he can like retrieve data. That's why every time he retrieves data, it's gonna cost him. Oh, sorry. So every time he tries to retrieve data, it's gonna cost him, but the cost storage is gonna be much cheaper than the standard one. But the retrieval cost for standard, it's much cheaper than the infrequent access one. So let's write this down so we can understand. So in the standard file system, we're gonna have two things. So the first one is gonna be higher storage cost, but vice versa, we're gonna have lower retrieval cost. Okay, so higher retrieval cost. But infrequent access is the totally opposite of it. So infrequent access, it has a lower storage cost, but high retrieval cost. So yeah, here we can see the diagram we have drawn, so we can understand that, of course, if you want to have something to archive or something that is cheaper in storage cost, but every time you want to retrieve something, it's gonna cost you a few. Okay, so what's the difference between them? As we said, that this is for frequently accessed data, so خد وأعطي. As you can see here, we have two arrows, one is sending and one is retrieving. So we have frequently accessed data. It's also highly durable and available. It's available across multiple AVs. The infrequent access one, this is designed for files that are not accessed every day. So we can say maybe backup file systems or anything like this. So you can see here, we've talked about this right here. Okay. So EFS lifecycle management, we have seen it here. As we can see, so we can transition into infrequent access. Of course, you can choose whatever you want. So if you haven't accessed this file system in 30 days, it's gonna move it to infrequent access. And you can move it even to archive, which is lower cost than infrequent access. It has the lowest storage cost and the highest retrieval cost. So yeah, here we can see if in 30 days we haven't access this file system, it's gonna transition into infrequent access, and if we haven't accessed it for like 3 months, it's gonna move to archive, which is for backups, maybe quarter financial files. And we can transition into standard if in first access. as you can see here. So we have EFS file system. It can automatically transition between the file systems. Sorry, guys. Okay, so we have seen that the EFS lifecycle management, it gives us the ability to transition between modes, and this is going to help us with cost management. So if we have data that is not accessed since 30 days, it's going to move to IA, which is infrequent access. And it's too big, I hate it. Let me, okay. So if we have data that we haven't accessed for 30 days, it's going to move to infrequent access. And if we haven't accessed this file system into 90 days, it's going to move to archive. So this is going to help us with cost management. But of course, if we want to retrieve this data, it's going to cost us a lot. Not a lot, a few cents, but it's going to cost us. Okay. Does anyone have any kind of question about EFS before we move to FSx? Okay. So if we went to EC2 instances and we try to launch an EC2 instance, you can see how easy it is to mount a file system. So if we try to create an EC2 instance, it's gonna give you the option to mount a file system. So let's check that out. So here, if you want to launch an instance, so I don't want to launch an instance. I just want to show you how easy it is. So here you can see that configure storage. We have talked about the ABS part yesterday. So before yesterday, sorry. And this is the 0 file system. So you can mount it to a file system. When you click on edit, here you can see FSx or EFS. And then you can create whatever you want. So I haven't created any kind of EFS, but if I did, it's gonna show up. See here, you have currently no file systems. And FSx also, you can create a new shared file system. We're gonna talk about FSx right now. Okay, so basically FSx is like EFS, but the huge and major difference between the two, that EFS is for Amazon and FSx is for third-party file systems. So we have 4 types of third-party file systems. So we can see here, if we created file system, we can see that we have NetApp on top, we have OpenZFS, we have Windows file server, and we have FSx for Lustre. So I think Lustre is for Linux. This is for Windows Server, and I'm not really, I don't have this much knowledge about these two. So let's start with Lustre's. Yes, here it is. You can see it's POSIX compliant. So this is used for, oh, sorry. So this is used for Linux. So anything with POSIX. So let's write this down. So POSIX, POSIX, is Linux. Where is our penguin? Here it is. That's huge. That's a huge penguin. I didn't expect that. A very huge penguin. Okay. So anything we said that is related to POSIX, it is related to Linux. Okay. So the key features of Lustre, we have high performance, it's low latency and high throughput. This is what we need literally. So low latency is what we need. We've talked about latency. It can integrate with S3 buckets, which we're gonna talk about. Object storage. It's scalable. It's POSIX compliance. Again, Linux, and it has a bursting performance. We have talked about the word bursting, which is a balloon. So cases, we can use it for machine learning, high performance computing, big data analytics, and media rendering, and genomics analysis. genomics, I think it's genomes. It's related to human genes. That's a really nice use case. Okay, so the next one is for Windows Server. So of course, it's gonna go with the SMB protocol, which is Windows related. It has an Active Directory integration. If you know about Azure and Microsoft, I think this is called Entra. Yeah, this is not Active Directory anymore. It's now called Entra. DFS namespace, and we're gonna talk about file system auditing, automatic backups, and high availability and multi-AZs. So DFS namespace. Here we can see it's a Microsoft thing. Okay, so use cases, of course, anything that has integration with Microsoft, like Microsoft SQL Server database, file sharing, home directories, backup and disaster recoveries, and anything that is related to Windows file server. So I think we have a Windows file server. We can server. So it is its own operating system, as you can see here. So yeah, it has a file system of its own. And even if we tried using EC2 instances, we can have a Windows server as the EC2 instance. So if you go to EC2 instances, we can see if we went to instances and try to launch one, we can see that we can have a Windows server operating system. It looks like the Windows that we have, but it can turn into a server. I think it's much, it has a better efficiency than normal Windows. So here and Amazon AMI, we can see Windows. Here we can see Microsoft Windows Server, Windows Core Base. So it is its own operating system. So let's go back to FSx. Okay, so the third one is NetApp on tap. So NetApp on tap, it has a multiple protocol access. It has network file system, SMB, and CSI. So this is capital I. It also has NetApp on tap features and it's high availability. So you can see that all of them are high availability, efficient storage, deduplications and compression, and it has data protection. So if we went to NetApp on tap, we're gonna see that it is a third-party application and you can use it on its own. You don't have to use it in AWS, but AWS gives you the ability to integrate third-party systems, as we've seen here. So the use cases for the use cases for NetApp ONTAP, hybrid cloud workloads, database and DevOps environments, backup and disaster recoveries, and block storage and shared file systems. So here we can see its own company. It's a third-party software. Also, this is duplicated, or I think, yeah, those are kind of duplicated, or I went back. Okay, so open ZFS system. We have a few key features. It's also its own company. So open ZFS. See here, on the software on another company. So it's high performance. It has snapshots and clones, data integrity, multiple protocol access. We have talked about them, and scalability. Key features. I think there's a lot of duplicated slides. So use cases, again, a lot of stuff. I don't remember that I have any kind of questions on FSx, but I think the most common one that about Lustre, that is POSIX Windows file server, that it has SMB, and Lustre is for POSIX compliance. Yeah, I think those what I remember. Okay, guys, so I think we have finished the file systems for today. But before we go, we said that we're gonna do our own architecture. So I want you guys to wake up and be with me and crack your fingers so we can get to work. So today, or our scenario is we're gonna create a simple web server, web serving system. So simple. I don't need notes. So let me put a heading, and we're gonna create our scenario. So our scenario, we're gonna create a web server, basically. Okay. So does anyone knows what kind of components make the web server? So what kind of things we need? So we need three things. It's called web serving. It's called three-tier architecture. So let's see. Let me give you a hint. So three-tier architecture. This is our scenario. Okay. So basically, if we want to create a web server, we need three things. We need a front end, back end, and something in between to process the logic of it, or a database, we can say. So we need three stuffs. We need the user. So let's get the user. So here is our user. This is a good one, I guess. Yeah, I should use this instead of me drawing one. Okay. And then we're gonna have our EC2 instances, which are gonna be, let's 1, 2, 3. Let me create 1, 2, 3. Okay. And then we're gonna need our storage. Either it's gonna be, I'm gonna choose, like, for the first thing we have got, we're gonna choose EBS. So here's EBS for everyone. So let's make it smaller. Okay, so guys, I want to say that if we remember at yesterday's lecture, we have talked about, yes, thank you, Muhammad. It's web tier, application tier, and database tier. Great. Okay, so we can use EBS to store stuff, but the problem is it's kind of like its scope. The ABS scope is for availability zone, one availability zone, not like EFS. So what is the problem with this architecture? Let's say that our client have entered his username and password or his information to this web server, and it's stored in this EBS volume. The problem is when he tries and he enters the same website and he gets redirected, or let me change the color because it's gonna show us in a different color as he went in a different time. So let's choose green. Oh, that's a very good green. Okay. So if the next time the users logged in into this session or this EC2 instance, all of his information is going to be stored in this EBS. It's not going to be stored on this EBS. So that's a big problem. The user is going to be very annoyed. He's going to like, do I have to really enter my information again? Like, can you imagine you have to sign up or like, let's give an example. Okay, you're trying to sign up to Facebook, and every time you want to log in into Facebook, you have to sign up. How annoying is that? So we understand out of this architecture that this has a very big problem, that if a user trying to log in into this EC2 instance and he enters his information on this EBS volume, the next time he logs in, he may be directed to this or this, and his data will be lost because it is not a shared storage. So we can, out of this problem, we can figure out something that instead of using EBS, we can use EFS for for storing this kind of data. Why? Because as we said, EFS can mount up to 100, can mount up to 100 EC2 instances across multiple AZs. And this gives us the ability to mount these 3 EC2 instances into that file system. So let's give it red. And now we're going to solve this problem that we had about the user login sessions. So another thing we're going to talk about in the next lecture is ASG or auto-scaling group and load balancer. So now we can understand that we have something that's called a sticky session or cookies, and then we have the basic understanding of scalability. Yeah, we're gonna understand the basis of scalability with the load balancer. We're gonna talk about CloudWatch metrics and alarms. So in this use case, we have created a 3-tier architecture. We have created 3 instances that is manual, so this is still not scalable. And we have connected it to our EFS system. So there's still much problem in this. So let's imagine if multiple users want to log into those EC2 instances, you're going to understand, okay, 3 users, like here's one, and okay, it's connected through the EFS. Of course, EFS does not connect using the EBS, it connects using NICs, as we said. So let's say AWS NICs, and let's get a picture of that. Yes. Elastic Network, ENI. This is the drawing of ENI. ENI. I want the icon, please. Okay, that's good. I think we can work with that. Or that's even better. No, that's a image. Okay, so AWS ENI or AWS EC2 NICs. Copy image. As we can see that, sorry. Trying to make this smaller. There. Okay, so we said that it is connected via ENIs or network interface cards that are related. So let me put this here. So actually, I gave these questions to my students one time, and in assignments, I said, if you want to connect EFS systems to EC2 instances, on how do they mount? We said it mounts using an ENI or a network interface card, and this is how the first architecture we're going to work on. So this is, again, as I said, this is still full of like flaws. It has no scaling. It's manual. If you want to scale, we can like enlarge, or as we said, it's vertical scaling. So we can add more CPUs, add more storage, but until then, this is still, it has many flaws. So I don't like this architecture. For me, I'd use full-on serverless services. And we're gonna talk about serverless, of course, guys, so don't worry. Okay, guys, so does anyone have any kind of suggestion we can add on this architecture, or do you have any kind of questions for today's lecture? It was very simple. It was very easy. But of course, I need to give some more, like, to warn you guys. This EFS and FSx file is not fully what is in the AWS Solutions Architect exam. So you need to study more about EFS. There's a few things that I haven't added because I don't want to make this lecture long. So you have to, like, there's a lot of things to study. And I can send you guys what things I haven't added if you want. So let me stop recording.